Hello there, biology world. Paulus here. Today I'm going to be delivering class notes for section 1-1 of the book. Likely we started taking these notes in class and you'll use this video to finish them up. Also, you can use this video to fill in missing spots if I went too fast during class. You can pause the video, go back and find what you missed, and then fill in those. You are welcome to handwrite them. If you are handwriting them, I need a couple things for you from you on your line paper. I need you to put your name in the upper right-hand corner. I need you to give it a title. The title would be 1-1 Class Notes or 1-1 CLS NTS. Also, what I need you to do is I need you to draw a line down the center of your page. Class notes have to be done in Cornell note style, and they also have to be numbered. The numbers will actually be shown to you in the PowerPoint, so if you want to get your paper ready, you can put a number 1 on the left. If you plan on typing your class notes, that is totally okay. I also have a document out on Google Classroom called Class or Reading Notes Template. I just simply need to download this or copy and paste it into a Google Doc, and you would just simply type in your name here, and then the assignment name would be 1-1 Class Notes or 1-1 CLS NTS, and of course you would just simply start with a number 1. If it does that to you and it moves the number 1 over, just to give you guys a clue, if you're using Microsoft Word, you can go to Home, click that, and it'll give you more space to type there. I don't really care if it indents it or not, but that's a trick that you can use. All right, let me go ahead and get back to the notes. All right. Okay, so what section 1-1 is about is just scientific observation, kind of the basics of science, scientific method, what data is, hypotheses. The reason why this image is in the book is it's encouraging you to make an observation. So obviously we have an ant. You wouldn't necessarily know this, but I do know that images that are blurry like this usually mean that we're looking at things that are very small. But what the ant has in its mandibles, in between its mandibles, is a microchip, a computer microchip. So basically the image is just encouraging you to make an observation. Of course, from the observation, you could form a hypothesis. I believe this ant is 1 millimeter long, and that, of course, would make the microchip smaller than 1 millimeter. Then, of course, you would have to figure out a way to measure it. Okay. All right, let's get started on the notes. So again, questions on the left side of your page, answers on the right side of your page. Goal of science, and we've talked about this a couple times. We did this in our reading notes example. This was also a warm-up question. So investigate and understand the natural world. By the way, I will be going a little faster in this video than I do in class, simply because you can pause the video if I'm going too fast. Normally in class, this would probably take a half an hour to 45 minutes to get through this PowerPoint. My goal is to get through the video in about 15 or 20 minutes. I will elaborate and talk about what you're seeing on the screen a little bit. And please, if I go too fast, pause the video to catch up. Explain events in the natural world and to use those explanations to make useful predictions. And I'm sorry if I'm kind of babbling a little bit. It's early in the morning here at the Paulus Pad, and I didn't sleep very well last night, so I'm not really awake, so I'll do the best I can. So what is the goal of science? Goes on the left. Those 3 bullet points go on the right. Next question, you can skip a line. You don't need to skip a line. Number 2, make sure to number them. Science, or what is science, or what is the definition of science? You don't need to write that. You just simply need to use science as a prompt. Definition of science is an organized way of using evidence to learn about the natural world. And what does thinking like a scientist mean? I am not a scientist. I do have a degree in conservation biology. I do have a minor in geology. I've studied a lot of science, but even though I am not technically a scientist, I do think like a scientist, and that gives me advantages in my daily life. Begins with observation, paying attention primarily with observation. And observation is the process of gathering information about events or processes in a careful and orderly way. And I do apologize that these notes are so wordy, but it's tough to cut stuff out and still have it make sense to kids. I will warn you when I'm going to the next slide. So if you are still writing, you can pause the video at that time. And that's kind of a good reason to have your volume on and listening to me rather than turning your volume down and listening to your own music or just simply having silence. Is because you're never going to know when I'm going to go on to the next slide. Of course, I suppose I could use a hand signal like that, and that's easy enough, but I'm sure I'll forget in a future PowerPoint. Okay, here we go on. So again, number 3, thinking like a scientist. The question goes on the left and the notes goes on the right. If you happen to not number them, or if you do not put your class notes in Cornell Note style, you will lose points because it takes me longer to actually check to see if you did all of the notes. So please do these in the format that I want. Please number them. You can do your reading notes in any format you want. Okay, what is data? The definition of data. So 4, question on the left. There are 2 types. There's quantitative data. And this was a warm-up question, if I'm not mistaken, recently. They're expressed as numbers, and we get those by counting or measuring, and they have units. I inserted quant, count, because those sound alike. If you are counting, it is a measurement, okay, of some sort. Qualitative data is descriptive. So an example of quantitative would be like 32 centimeters or 72.3 minutes, 42.9 kilograms. Qualitative data would be like, it took a long time. It was really heavy. It was really cold out. So it still tells you something. It just doesn't tell you the number, and it doesn't tell you the unit. It is non-descriptive data. Obviously, it's better to have descriptive data, but sometimes using qualitative data is good enough. Definition of an inference. An inference is a logical interpretation based on prior knowledge or experience. So a lot of kids get inference and hypothesis mixed up because a hypothesis is an observation which leads to prior knowledge. An observation is a previous experience which leads to knowledge. So an inference is kind of like a suggestion, but usually it's a little bit stronger than a hypothesis. A hypothesis has not been tested. An inference, you actually have some experience with whatever situation you're thinking about. Sorry about that. Forgot to do this. Some of you guys are still writing. I'll give you guys another 30 seconds or so. The next slide is a check for understanding slide. Normally when I have kids in front of me in a classroom, we use whiteboards, or I just simply have them refer back to their notes and I ask random people questions. Obviously, I don't have you guys in a classroom in front of me. And rather than spending a lot of time asking you to write down answers or look at your notes in class, I'll just simply give you a couple seconds. I'll tell you where to look, but it's an opportunity for you to practice with your notes. So during the video, I would encourage you to look back. I'll tell you where to look to find the answers if you don't know what they are. But remember, every minute that you spend practicing with your notes during the video or during class is less time you're going to have to spend preparing for the tests later on. So I really would encourage you guys to spend some time going back and looking up the answers, because every time you read it, it's more likely to stick in here. Okay, I'm going to go on to the next slide. And again, these are practice slides. Okay, these are not things that you have to take notes on. And the obvious way to recognize that is they are not numbered. One of the goals of science is to use explanations to make blank blank. Try to come up with the answer on your own before you look it up. But if you can't remember what it is, take a look back at the third bullet for number 1. Give you guys a couple seconds to do that. All right, that is useful predictions. Wearing all my Mets gear today. It's kind of a sad day for the Mets because we were supposed to be playing the Yankees in the Subway Series all weekend, but a member of the Mets team and a member of the Mets staff tested positive for COVID, so they are not playing those games this weekend. Hopefully it's just limited to those 2 individuals. I'm a big baseball fan. Scientific thinking begins with 2 choices: observation or thought. And if you're not sure, take a look back at number 3 in your notes. And again, another reason why it's important to number your notes is because I can point you to where to go to practice with your notes. I can't do that if they're not numbered. All right, a couple more seconds. It begins with observation. All right, quantitative data is blank, while qualitative data is blank. Whenever I have a word and a, what do they call those? Slash. This means that this one would go in the first blank and this one would go in the second blank. Of course, if you think it's this one would go in the first blank and this one would go in the second blank. So quantitative data is that measured or descriptive. Qualitative data is that measured or descriptive. And of course, you want to look back at number 4. And of course, quantitative data is measured. You use tools. It has numbers. It has units. Qualitative data is descriptive, not specific. Okay, moving on. Okay, please number 6. And how do you explain and interpret evidence? That goes on the left. And then the notes goes on the right. Hypothesis is a proposed scientific explanation for a set of observations, and it can be ruled out or confirmed, and we use experiments to rule out or confirm hypotheses. I think the definition in the book is a statement about an observation, so you can simplify that definition if you want. It is kind of an educated guess, and the reason why it's an educated guess is because you've actually made an observation. And you could use an experiment or a set of steps to confirm it or deny it, and that would be ruling it out. How do you propose a valid hypothesis? Must be proposed in a way that can be tested. So you have to be able to use a controlled experiment where you have one variable that is being allowed to change or is being altered. That's the manipulated variable. All the other variables have to stay the same. Those are controlled variables. And if you do that, then your result, your responding or your resulting variable should be able to confirm or deny that your hypothesis is correct. And again, I do apologize for going so fast. It takes me time and effort. I still have to save this to my Google Drive. I still have to upload it to YouTube. I still have to wait for it to load on YouTube. Then I have to approve it for San Juan on YouTube. It takes me some time, so I don't want to spend all that much time making the video. Research teams and conclusions. We kind of talked a little bit why we use research teams in the scientific method class notes. They often work as teams to analyze, review, critique each other's data and hypotheses. When I'm doing complex things, so when I'm working on the house or when I was used to work on my car, I always liked to have somebody else there. One of my favorite people to give me help is my buddy David. David is super smart, builds stuff, figures things out. He's just got a brain that's wired a little bit better than mine when it comes to those things. And it's just great having him around to ask questions too. Sometimes he doesn't have to be there, but I'm just like, hey, you're going to be available near your phone, for a couple hours. I might want to bounce something off of you. And that's simply because simple things that I miss, he might not miss. Okay, and that's why scientists usually work in teams, is because they can help each other through the process. A valid conclusion must be based on a logical interpretation of reliable data. All right, again, a lot of words up there. And I really, if you have a word processing program, or if you know how to use Google Docs, I really would encourage you to type your class notes and to type your reading notes, because it's a lot easier. You could type this, assuming you're a decent typer, in way less time than it would take for you to handwrite it. But personally, I don't like typing notes. I like taking handwritten notes. I learn better. The reason I think I learn better is because it takes me a little bit longer and I have more time to practice with the information, and I'm actually seeing it slower. That's just me. But I do understand that taking notes by hand does take some time. And unfortunately, in this virtual world, you'll be doing a lot more of it than in my normal classroom. And hopefully we're back next semester and you'll know what I mean. Note taking is a lot easier when it is in person in my classroom. All right, I'm ready to go ahead. All right, scientific process, ask questions, or having a question, or identifying a problem, making observations, making inferences, testing hypotheses, not necessarily in this order. We're almost finished. Section 1.1 is pretty short. So, human importance of knowing the scientific process, even if you don't plan on studying science in college, even if you don't plan on going to college. I mean, college isn't for everybody. My wife didn't go to college and she does just fine. Having an understanding of the scientific process will give you an advantage in life. For example, yesterday, my wife and I were at Home Depot. We saved a lot of money this summer. Lots of families saved a lot of money this summer because we didn't go camping. We didn't go on our vacation to Mexico that we were planning. So we saved a lot of money, and we decided that we would do some things around the house. We were at Home Depot last night ordering a door. We're getting a new front door. And we had somebody out about a week ago that needed to measure to find out exactly what doors would work for our space down there. And the gentleman we were working with last night said, so-and-so indicated that, I don't remember exactly what the term was, but it's the wood that actually goes underneath the door, that he had seen some dry rot and that he recommended that be replaced. And of course, I just started seeing dollar signs in my head automatically, and it kind of made me mad because he didn't mention that when he was actually out doing the measurements. And I haven't even looked at that piece of wood to confirm or deny that it looks suspect, which really made me nervous because I didn't have an opportunity to make an observation, and I didn't have an opportunity to think about whether or not truly does need to be replaced or does not need to be replaced. I'm going to go ahead and throw the notes up there for those people that are still writing. So it's essential in making intelligent decisions. So I needed to have that observation to make that decision. As it turned out, I said, okay, I didn't make the observation. I can't make an argument agreeing with or disagreeing with that. How much extra money are we talking? And he said, oh, well, the piece of lumber is going to be like, probably $7 or $8. The labor is probably going to be like an extra 15 minutes worth of work. So, probably an extra $20. And I'm like, oh, if we're only talking about an extra, $30 or $40 when we're putting a $3,000 door in. I had no idea doors were that expensive. Granted, we have a double door and we're condensing it to one door with the side panels. But if we're only talking about an extra $20 or $30, when we're talking about in the grand scheme of things, $3,000, that's not that big of a deal. So, but If it was going to be hundreds of extra dollars, I would have probably said, time out. We'll come back and meet with you next week. I need to go home and take a look at that. I need to make observations to make intelligent decisions. Just having an understanding of, like, when I take my car into the shop, I used to work on my car. I used to drive cars that were made in the 70s and the 80s, and my dad taught me how to work on my car and do brake jobs, do oil changes. I even installed engines with him. So I have a basic understanding of how cars run and what the parts in the cars are supposed to do. So, and if you have that knowledge, when you go into a shop to drop your car off and you start asking some intelligent questions, and this is what this is what the car's been doing, and I think it's this, and this is why I think it's this. And if you sell to the person at the shop that you have a basic understanding of how cars work, you are way less likely to get burned. Okay. When they replace a part, I always tell them, if they're replacing something, I want to see the old part. Put it in a box. I'll go ahead and throw it in the garbage can when it gets here, or I'll recycle it, or whatever the case may be. I want to see the part, because I want to know that you truly did put a new part in there. And hopefully the part is, within view, and it's not like hidden inside of some casing. I always try to confirm that indeed work has been done. If you think like that, you are way less likely to get burned, and you're way less likely to get to become a victim. My wife isn't as good at that as I am, and she relies on me, but really understanding how things work and making observations and asking questions, and talking to people will save you stress and save you money in your adult lives. So that's why knowing the scientific process is important. Well, one of the reasons. Okay, again, not writing this down. A proposed scientific explanation for a set of observations. What do we call that? And if you're not sure, take a look back at number 6. 2 choices: a hypothesis or a conclusion. Couple seconds. Right, that's a hypothesis. Good. What are 2 ways a hypothesis can be tested? And if you're not sure, take a look at number 7. So you can use a controlled experiment, or you can gather new data. And sometimes in an experiment, you're actually gathering new data. All right, science is an ongoing process that involves 4 things. What are 3 of the 4 things it involves? And if you can't remember, take a look back at number 9 and just try to remember all 4 if you can. Again, number 9, ask questions, make observations, make inferences, and test hypotheses. Last question. An understanding of the scientific approach allows humans to make blank, blank. And if you're not sure, might want to take a look at number 10. It allows humans to make intelligent decisions. Okay. Some of you guys are going to stop the video here because we're done taking notes. I would encourage you guys to stick around for a few minutes. There are always multiple choice questions at the end of the notes. I got these from the people who made the book. And likely you will see these questions on a quiz or a test. So maybe not necessarily necessary to write them down, but what I would at least do is maybe take some photographs of these questions and the answers. Wait till I show you the answer, and just have them on a phone. Maybe you can use your images on your phone as flashcards when you're getting ready for a test. Observations involving numbers are known as, so what type of observations? Wait, this was a warm-up question. Numbers use tools. They have units. They are measured. Those are quantitative. Quant, count. quantitative observations. Good. All right. You guys did a warm-up question very similar to this, too. Scientist takes paint chips from 10 apartments in a large building. She tests for the presence of lead in the paint and finds that in all 10 samples. She then concludes that lead paint is probably present in all 120 apartments in the building. This conclusion is an example of scientific fact, scientific error, proof or fact, or a reasonable inference. So first of all, ask yourself this. Has she tested all 120 apartments? No, she has not. So it can't be fact. And it also can't be proof. All right. Scientific error, we don't know yet. I mean, you would have to test all 120 apartments to find out if it's an error. It's an inference. Remember, an inference is based on previous experience or previous observations. She's made previous observations and she has that experience, so she can make an inference. Okay. Next one. A possible explanation for a set of observations. What is that the definition of? Possible explanation for a set of observations, data, hypothesis, inference, or result. Statement about a set of observations is referred to as a hypothesis. Some of you guys might be wondering, why did we skip a number? We went from number 1 to number 3. Sometimes the questions that they give me or the notes that they give me, I don't feel are as important. So I've cut some of the stuff out, changed some of the stuff. And if there's a question tied to information that I cut out of the PowerPoint, I'm obviously not going to ask you about it because you probably don't know the answer. So that's why sometimes the numbers skip. A good scientific hypothesis must be correct, able to be tested, obvious, or based on common sense. A hypothesis must be able to be tested, okay, by a controlled experiment or by collection of new data. All right, kids, that is it for the 1-1 notes. A couple things to remember. If you are writing these, please take a picture in a well-lit area or use your flash. After you take a picture of your pages of notes, please look at the picture on your phone and make sure that you can read everything, because I need to be able to spot check your notes to make sure that you're taking notes on the right section. If you type these up, you're going to save them as a Microsoft Word doc or whatever word processing program you're using, or you're going to save your Google Doc, and then you are going to upload this file to Google Classroom. Obviously, if you're taking pictures, you're going to upload those pictures to Google Classroom. Please do not share your Google Doc with me for editing. It's going to come to my email address, and I'm just going to delete it. I always go to Google Classroom to check on your work. Same thing with images. You're just going to upload those images to Google Classroom. If it's more than one, I just simply click on the image and I blow it up a little bit so I can read it and make sure it looks good, and we will be good to go. And of course, if you ever have any questions about what you're supposed to be doing weren't answered in this video, you are always welcome to email me at apaulus@sanjuan.edu. All right, I hope you guys have a nice day, and thanks for watching my video.